Let's consider this simple exam question, which can confuse a beginner in calculus. Step number 1. Differentiate tan x. From basic derivative table, if you differentiate tan x, you are going to get sec squared x. Hence, dy dx is sec squared x. You might probably want to choose none. However, from basic trigonometric identity functions, tan squared x plus 1 is equal to sec squared x. We are choosing this because the question got tan x in it, and the derivative gave us sec squared x. I'm going to write tan squared x plus 1. Next, in step number 2, instead of writing sec squared x for my dy dx, I can replace it now with tan squared x plus 1, which I got from the basic trigonometric identity functions table. Subsequently, if y is equal to tan x, then y squared is equal to tan squared x, and this is the same as this. Both are the same. In step number 3, instead of tan x, I can now replace it with y. Hence, we are going to have y squared plus 1 instead of tan squared x plus 1, which we actually replace sec squared x. From the options, our answer is A. Next, consider this question. Given that y is equal to cos x, then the second derivative of y minus the first derivative of y squared minus 1 is step number 1. Differentiate cos x. From the basic derivative table, when you differentiate cos x, you are going to have minus sin x. Hence, the differentiation of cos x will give you minus sin x. This is the first derivative. Next, in step number 2, we are going to find the second derivative. Next, the first derivative got a minus. Hence, this will have a minus. Next, we are going to differentiate sin x. From the basic derivative table, when you differentiate sin x, you are going to get cos x, and we are going to have minus cos x. Next, in step number 3, we are going to consider the given condition. Next, step number 3, instead of the second derivative of cos x, we are now going to have minus cos x, and instead of the first derivative of cos x, we are going to have minus sin x. However, there is a squared. Recall that minus 2 in bracket squared is the same thing as 2 squared. It is the same thing as 4. Hence, I can let out and I'm going to write it like this. Next, in step number 4, I want to make this identical. Either to make it cos here and cos here, or this to be sine and this to be sine. To achieve this, from basic trigonometric identity functions, sin squared x plus cos squared x is equal to 1. Hence, in step number 4, instead of sin squared x, I will now write 1 minus cos squared x, which we obtained from this identity by making sin squared x the subject. Hence, I've achieved my aim by making all the identity in the function to be cos x. Next, you open up the brackets. This minus will multiply this and you have this. This minus will multiply this and you get a plus. Next, rearrange the function. Let cos x be k. Then we can say k squared minus k minus 2. And here we can say let it be equal to 0. And this is quadratic equation. Step number 5. By factorization method of quadratic equation, we got k is equal to minus 1 and k is equal to 2, which is same as saying cos x is equal to minus 1 or cos x is equal to 2. We got minus 1 and 2, and from the options we got C, which is minus 1. This is calculus. In the next video, we are going to consider differentiation by the first principles. These are recommended video topics in differentiation, and also some suggested video topics in integration, including their applications. To solve differentiation and integration problems efficiently, always remember these formulas and notations. Including precalculus video topics. I will see you in the next video.